And we recorded. Cool. Okay, so welcome to the CodeAlong during the weekend thing. Wait, what? I can't minimize Zoom when I'm recording? That's dumb. Okay, well, I'm just going to go ahead and share my screen then. Nerd. So welcome to the CodeAlong. We're going to go through and code some stuff. I don't know. So the main idea of kind of how we're going to get started here is we need to figure out kind of how ROS can structure it itself and what it does. And by what it does, I kind of mean like how it's going to be storing programs. And the way it does that is through something called packages. So the idea is that if you have a project, pretty much all of the files for that project itself are going to be held inside of a package. So you got Catkin workspace is the entire thing. Inside Catkin, you're going to have packages, and inside those packages, you'll actually have your programs. That's kind of how that's going to work. That's just kind of how it's going to be. So let's go ahead and make a package because that's fun. So all you're going to have to do is go ahead and navigate to your terminal. If it's not on the sidebar here, you can just go down here to the three dots and click Show Applications, type in Terminal, and then it'll pop up. And if you hit right click on that and do Add to Favorites, it'll throw it on that right bar for easy access. Yeah, so right now we are in the home directory as referenced by the blue tilde there. I know you probably can't see that, but the blue tilde means your home directory. And what we're going to do is we're going to go ahead and navigate to the, geez, this is weird. We're going to navigate to the source directory of our Catkin workspace. Now, you should know how to do this if you watched the Unix video or if you know any sort of Unix at all. But the way we're going to do that is we're going to go ahead and do CD for change directory. And then for me, my Catkin is right under my home, so I can just type in Catkin. If you put it somewhere else during that ROS installation video, you're going to want to go ahead and navigate there. So now we're in Catkin, and we've got the build, devel, and source. So we're going to go ahead and go into source. And you'll notice when I list, I actually already have a package from when I recorded this video. But we're going to go ahead and make a completely new package. Yay, whoa, cool. So you're going to be able to name this package whatever you want. And I guess I should say right off the bat that, again, this is not any secret hidden knowledge. This is literally, I'm grabbing what I'm doing here from the, wow, this is being weird, from the ROS Wiki creating package tutorial. So if you're looking for any specific commands, that's literally where I'm getting them. Yeah, so anyway, now that we're going to go in here, we're going to go ahead and type the command catkin _create _pkg for package. And then do a space and then the name of your package. So you can name it whatever you want. For now, I'm just going to create or call it, I don't know, tutorials. Sure, that's a weird, yeah. Tutorials, and then you're going to do another space. And now we need to add dependencies. And what dependencies are going to be is they're going to kind of be the packages or the code that your main program is going to reference to use functionality from. The idea is that, you know, if you're a programmer, you know this, that the program that you write is also going to be utilizing tons and tons of other code. So that's the exact same with ROS. So we need to add some of these dependencies. And there's three main ones that we're going to add, and you can add more later, and I'll show you how to do that. But the three main ones that we're going to add are std for standard _msgs for standard messages. And we'll get into what those are later. We're going to add ROSPy. And what ROSPy is it's essentially a collection of commands and code that our ROS program can utilize when we're writing in Python. So there's going to be a lot of different little things that we're going to be writing that are Python specific that ROS knows what they are. And then likewise, we're going to add one for ROS CPP, for ROS C++, and it's the exact same thing but for Python. So now the idea is you could actually have programs in here that are Python and C++ and have them still talk to each other because they can both run inside your package. Once you've got that, go ahead and hit enter, and you should, if I type that out correctly, get this. So you'll see that it created a couple of files and a couple of folders. We're going to look at both of those files being package.xml and cmakelists.txt. But for now, we can go, oh, yeah.
We're getting errors saying the following arguments are required
Ah, okay, that is a very, very good point, and I completely forgot about that because I did it in the video, but I didn't do it here. Give me a second. So what's happening, and it's a very, very thank you, very, very good point, is ROS is complicated in that it uses a bunch of commands and you have to, I guess, tell your terminal where to look for those commands. And the way that you're going to do that is by something called sourcing. So what you should type out here is go ahead and type in source/opt/ROS/noetic/setup.bash. So if you go ahead and do that, it'll source that file. It'll basically say you can look for commands here now. And the other place that we're going to have to source throughout, I guess, yeah. Whenever you make a new terminal, you're going to have to source, which is kind of a pain. So if you go up here and click new terminal and do all of this, you'll still have to source. It's a pain, but there's a way around it. Essentially, what you can do, and again, I'm getting this from online, is you can go echo, and then in quotes, your one above. So it'd be source slash t slash noetic or slash ROS, sorry. Slash noetic slash setup dot bash that, and then two of those guys, tilde slash dot bash rc. And I'm getting this from the ROS installation noetic page. And then once you hit that command, go ahead and do source that tilde, should be tilde slash dot bash rc. And now whenever you open up a new terminal, it's going to go ahead and run that anyway. So now you don't have to worry about doing that. So now if you go ahead and run that command again, which you can do just by hitting the up arrow a couple of times until you get to your cat can create package, you should be able to create it now with no issues. Yeah. Yes, there should be a space there. I was going to say, yeah, I totally did that there. So, yeah. What do we got? Oh.
The only difference in space in my attitude.
You go to so CD and then go to slash off and then know ROS is the just keep going down and see if that actually got that file on it.
Yeah.
Stuff actually is there.
That one.
Oh, okay, so you have to edit the bash recipe because it's gonna be in there. So go to CD and tilde. Go ahead and get back out here. You do nano dot slash or nano dot bash recipe. Okay, cool. Scroll it all the way to the bottom. Yeah, okay, you're trying to keep the yeah, just leave those two lines. That should let you know. Yeah, it's fine. Enter. That should be better. Also do the source bash recipe. Or not. Well, it should be okay. There we go.
Good? Yep. So are you able to run that create package command again? So you could probably have another one where you have to source the double file, but we don't have to deal with that now. I don't think I dealt with it in video, so I can make a new one honestly. What? Does it say it exists?
But I didn't, it didn't work, I recorded it. Okay, I created it, it said errors, you can't do that, and I didn't try to do it again.
I mean, if it's there, try going to CD. No, you got everything. No, that's fine. Yeah, he added, but it's probably fine. Yeah. So if you go through that command and it says that you've got those things created, you should be able to see, okay, we've got a tutorials package, go into tutorials or whatever you named yours, and we should have a include, CMake list, package.xml, and src. Now, the package.xml and CMake lists are very, very simple. We don't really need to worry about them too much. But I guess I can go through and kind of show you guys a little bit of what's inside of those. So you'll want to open up that package with your favorite text editor. Mine is VS Code that I've got on this image. If you want VS Code so you can be cool like me, you can find it in the Ubuntu software and then just typing in. What?
I could put you guys download this.
I think it's in one of the videos. Oh no, don't look at my crappy code. No.
Why would you set something like that and then not use switch cases?
Switch is forbidden. We hate switch statements.
Yep, totally.
Not that one. Yeah, no. Let's see here. So,
I said we probably had a C++ program in Visual Studio that had terrible memory management. How much RAM should I be using with that? 18. Max? Yeah. You can give me more?
version work.
Oh, okay.
So navigate to your favorite one, or navigate through your favorite text editor to your tutorials package. Go ahead and open that guy. And then if you go, you'll see that we have a source folder, our include folder, and the two files. It's literally what's there. If we go into the package, this one is the more complicated of the two, but it's also very simple. And what it is it's essentially just here is our package, here's our project, here's just some info about it. So you've got a description, a name. By the way, if you guys have a question, feel free to just interrupt. Or I guess if you need me to slow down. I guess, yeah, you could probably open it in Nano. Oh, yeah, I guess I could go through and do that. If you don't have VS Code, you can go ahead and open this via Cat or Nano by doing Nano, Nano, and then the thing, so if we're going to do package, and then if you open it, you'll be in a text editor that's like this. And you can go through it like this. Yes. So if you want to, I guess if you don't have a text editor installed that you want to use, you can go ahead and use the built-in text editor in Unix called Nano. And the way you do that is make sure you're in the directory that has the file you're going to be reading, essentially, and type nano and then the name of that file. And then once you type nano and the name of that file and hit enter, you'll get brought up into the file. This is the package.xml file. Yeah, so you'll be able to see the exact same stuff. So we've got the email of the maintainer, the license, which, I mean, for college robotics, I think we might need to maybe adjust these one day, but it's not that big of a deal for anything we're doing in particular right now. The things to note here is that you'll see that it is building and executing with dependencies, and I guess exporting with dependencies as well. And these are the exact 3 dependencies that we put into our package via that terminal statement. Okay. In CMake lists, it's very much just not that huge stuff going on. It's a lot of just regular text. Again, you'll notice that there's some required components here that we put in there. And then I think there's like a list of executable files is the only other sort of notable thing to know in here. But we won't really be touching these files too much throughout, especially for today's little tutorial type deal. So the first thing we are going to do is create a new program. And for this section, I would highly recommend having a text editor that is like VS Code or something other than Nano. So if you want me to walk through how to install that, now is the time. Yeah, okay, that's fine. So if we are on, let me just get out of this. We are on our desktop, regular. We're going to go over to the orange little shopping bag here for Ubuntu software. Pack up here, and then we're going to click on the magnifying glass in the top left and type Visual Studio, and it should pop up with a blue VS Code and a teal VS Code Insiders. We're going to go ahead and click this blue VS Code, and then there should be a green install button right here. So go ahead and click that install button, and it should take a second, but it should install for you. And once it says installed, you should be able to close out of this window, go down to your show applications and find it there. So, yep, we can wait a second while it downloads because it does take a second. Don't judge me too bad.
What are you drinking?
Oh, some Twisted Elixir Bubbler is, you know, we're not sponsored yet, but, you know, Bubbler, big brain move, hit me up for that sponsorship. you just imagine UNL RMC sponsored by Bubbler, the official drink of UNL RMC.
I don't know if Nebraska would be very cool with that, considering I think only Pepsi products are allowed to sponsor. I'm not sure if they'll put Pepsi products.
They sell it in the C-stores.
Doesn't need Pepsi products.
Fair enough.
So is there something I need to be doing to get what we have now into?
Oh, yeah. So, no. So VS Code is actually a glorified text editor, is really what it is. It's a very good text editor. And if you're a programmer, you have a very, very good chance of using it in your future. And if you're not, you're probably doing something wrong, in my opinion. So if you click on the blue icon, whether it's on your favorites bar or through the show applications, and you go to File, Open Folder, and then you'll want to navigate to where that tutorials or whatever you named your package is. Should be able to find it through Catkin, Source, and then whatever you named your package. So you should have an include package.xml and a source, and then go ahead and click OK in the upper right, and you should get this on the sidebar.
Okay, now that you use code in a bunch of, if you go to your terminal, and like CD dot, you go back to that, you can open up the tutorial thing, just like in code and in tutorial. And it will open that folder in VS Code.
Okay, that's kind of huge, actually. That's really huge. Yeah, so are you here? Perfect. Is everyone else in a good spot to move on?
Yeah.
Cool. Who's ready to actually start coding? I am, trust me. What? So we're gonna go ahead and make a folder inside the source. So make sure you click source, and then you can hit new file, and it should, bring up this little box right here, inside source, and you'll know it's inside source by this little line right here. I know you can probably barely see that on the screen, but that's how you know it's inside. And what we're gonna do is we're just, yeah. So So make sure you click on source so that it's blue, and then you're gonna go and click this top left icon. And when you hover over it, it says new file. Click on that, and it should bring up this right here. And we're just gonna say this is, we're just gonna call it sam.py. So just type whatever you really want to call it, and then .py. The .py is,
You know how many things then?
it's okay because this program's gonna be making fun of Sam. You can name it whatever you want. The important part is that you have the .py at the end of it, and you'll notice the little icon.
What if I want to use like Ruby program?
Please leave the classroom. You'll notice that the symbol changes to the little Python symbol, and that means you've done it right. Hit enter, boom, now you have this. And now we are ready to actually start coding. It's been a while.
I'm not sure if they'll turn to the Python thing. Well, I guess I don't know if you have extensions, so we.
I don't.
So I guess it works with that.
Yeah.
It's clear enough.
You can, yeah, you can. It, like I said, VS Code is a glorified text editor. If you don't know what you're doing with it, I wouldn't recommend installing random extensions. For myself, I usually have a couple of them that I do, and I might actually install one of them just so that you guys can kind of see indentation a little bit better.
There's a ROS extension which will automatically install a Python and C++. Because there's literally extensions for everything. So if you search ROS, there is an official extension
By Microsoft.
for ROS. Yeah.
Okay. Yeah, so if you do the show recommended or just install for that one, what it will install for you is this one right here, Python by Microsoft, which is good. It just kind of colors things for you. It makes it a little bit easier to see. It's honestly up to you what you do. I also have, I believe I just have, do I have Rainbow? I'm pretty sure, yeah, I have Rainbow indented just so that it's easier to see. But other than that, that's pretty much all I have. There's really, you can mess around with VS Code later and figure out what works for you. But you can realistically do everything we're going to do today with 0 extensions whatsoever. So we are in sam.py, and the first thing we need to do is tell Ross or tell this program that it's actually in Python. Now you might be saying, Justin, what the heck? It says it's sam.py. But Ross, that's not good enough for Ross. Ross needs to, that's not good enough for Ross. Ross is picky. So the first line of every single program you're going to do is you're going to be telling it what sort of environment to be using. And the way we're going to do that is we're going to do a £, exclamation point, /USR /bin /env space Python 3. And it should be a comment color. Yeah, I'll go through that again. So the £, exclamation point, /user, USR, /bin, I can actually write it up here. Where's my backpack? /env space Python 3. And what that's going to be doing is telling us, what is it? Space here. And that's telling Ross we're using Python 3. Okay, so now it wants, essentially we're telling Ross, read this program that we're going to write in Python 3 and execute that. So now that we've got that, we need to have a starting point. If you're a programmer, this is basically your idea of a main method or a, thing that just starts your program. So the way that we're going to go ahead and initialize this is if __, and you'll notice that some stuff pops up from a couple of other code snippets. We're actually going to use this. Is this the Ross thing? I think this is Ross.
What?
I think this is the, yeah.
Is there a space after it?
Yes, if space __, and we're going to be using this one right here, which is name __, equals. I know this is kind of a mess, but this is just how it is. You can copy and paste this for most of your programs once we get a basic template.
Default path.
Huh?
Default path. You'll see.
Okay. And then you're going to put this next part equals, and then inside single quotes, __, main __. So every single time you see underscores there, it's 2 of them. And then after that next quote, a colon. And in Python, a colon is basically we're starting a program. We're starting either a loop or a method or a function or something like that, a conditional. That's what the colon is telling us. So that colon says, boom, we're starting a thing. So essentially then you hit enter and you'll notice that there is a indent here. In Python, indentation is incredibly important. You'll notice there are no curly braces from a lot of other languages such as Java for people who are learning how Java or C# or something like that. So indentation is very important. It is very important that you only use tabs or spaces and not both, or else Python will not compile and it will get mad at you. So make sure that if you're doing stuff to kind of let it indent, or you're just very careful about how you indent. And you will save yourself a headache in the future, because that took me a while to debug. Anyway, and then inside here, we're just going to do start with open and close parens. And that's basically saying go to the start method. So now that we are saying go to the start method, we should probably actually write a start method. So the syntax for creating a method in Python is def, and then we need to call it start so that it's saying go to start. Open and close paren for parameters if there were going to be any, colon saying this is a function, and then enter, and you'll notice that it's indented again, which is good. So this is kind of where, yeah.
Parentheses or curly?
Parentheses. I don't think we use curlies at all in Python.
You can.
You can, but I don't think we do.
I mean, the only reason I do it is because I'm used to using curly braces.
If I, will it adjust? Oh geez, is that better? Can you guys read that better? It's good? Okay, cool. So now, oh geez, this is weird. Okay, so in the next part, what we're gonna do is we have to tell Ross what the name of this node is, and we'll get into that, why. Well, I guess it's kind of in the structure video a little bit. But we need to basically say, Ross, this is what you should be calling this node, and we'll get into why later. But so the way we're going to do that is Ross pi dot init underscore node, okay, open paren, single quote, and then whatever the name of your program is called. So if it was called Steve.py, we do that. Or in our situation, it's Sam.py.
And we're getting open.
Sam.py, and then you can just do the single param, close parentheses. And then you're going to enter a couple of times. Notice it's going to keep this indentation, which is important. This is going to be, I'm just going to kind of put this as a comment. You don't have to if you don't want to. But this is where we're going to create our variables, publishers, and subscribers once we get there. That's kind of be where that happens. The next part of code we're going to put in here is what's called a rate. And the idea, at least with robotics, is we essentially want our program running all the time. So we need it to be running all the time, but our computer runs really fast. We don't want it to kill itself. So essentially we want to say, hey, run all of your instructions. Wait a second, run all of your instructions. Again, essentially. That way, for us, we don't see the difference between it running consistently, running constantly, and and having that little break in there. But to the computer, it makes the world of difference. So we're going to do a rate equals rosspy dot rate, uppercase, open paren, and we're just going to do 10 for now. And what that translates to is about 10 hertz, which I believe is roughly, I believe it's like half a second or 1 second. I think it's something around there.
10 hertz would be, what, 6 times a second?
6 times a second? Don't make it. Sure.
I might be wrong about that.
Whatever. This will work for what we're doing.
1 over second, so. Sure. 1 6, so 6.
Nice. Let's see. The next part we're going to do is we got to make a while loop, essentially, for our program to run. So we are going to do a while, and then the condition we're going to use is while our robot is not shut down, which sounds weird, but if you think about it, it kind of makes sense. You want your program to be running. You want that while loop to be going while your robot is alive, right? So we're going to do a while not rosspy dot is underscore shut down. Yeah, it's a weird one, I know, but that's how it is. And then we're going to do open paren, close paren, because rosspy dot is underscore shut down is a method, so that's how we're going to be doing that. And then we'll do colon, enter. And you'll notice now we have a second level of indentation for the while loop. And then this part of our program is where we're going to be doing stuff. So this is where the main functionality of our program is going to be, whether we're publishing stuff, whether we're printing stuff, whatever. What are we going to do? So for this very simple program, all we're going to be doing is having our program print something to the screen. Now you can have it print whatever you want. Since this is a program that is Sam, I'm just going to have it print. I know how to code. There we go. And that's all it's going to do. Is that's what it's going to print to the console. The next thing we need to do is if we just ran this as it is, it would run very, very fast and the computer would get very, very sad because it's running constantly. So we need to actually use that rate variable that we defined above. And the way we'll do that is we will do a rate or whatever you called it here. You'll notice these are the same, right here and right here. Rate dot, sleep, open paren, close paren. And that's all that our while loop is going to have, is those two lines. Very, very simple program. So we'll hit enter again. You'll notice we still have that indentation there again. But we want to be outside of the while loop. So you can hit backspace and you'll notice it, jumps down to that 1 again. If you hit backspace twice, so you're here, that's okay. Make sure to hit tab once to get back there. And you'll be good to go. And the last piece of code we need for this is kind of a weird thing to think of conceptually, but essentially if our program stops running for some reason, we want it to restart while the robot is active. Does that make sense? If for some reason our program stops running, whether it's from a crash, an overload, or something, and the robot is still running, we still want it to run, so we want it to restart. Does that idea make sense? Why we might want that to happen? Yeah. So the way we're going to do that is we're going to do rospi dot spin and then open paren, close paren. And just like that, that is a very, very simple node and ROS. Very, very simple program to write. Go ahead and hit Control S and we are ready to run it. We are ready to go. So head on over to your terminal. And the first thing we're going to do is we are going to essentially compile the entire program. So we wrote the program, it's good, ready to go. You'll notice that there were no syntax errors there, but there could still be runtime errors, and those might still pop up. There is something that can sort of help catch those or sort of build everything, and that is a command that we're going to do that is the cat can make command. Now, before you do this command, we want to be in the workspace, not in a source folder, but in the actual workspace. So the way we're going to do that is cd ... Because if you remember from the Unix video, ... references the parent directory, or the directory that's above your current directory. Okay, hit enter, and boom, we're in the catkin workspace. And if you go ls, you'll notice that we have our build, devel, and source. So cool, ready to go. The next command we're going to do is catkin _ make. Yes, Lauren.
That is not what's coming up for me. I'm getting C make with that.
So for you, it was probably, you'll know that you're in the workspace when you have /catkin workspace and there's not anything after that. Cool. So you should be able to do catkin make. We'll see if it gets angry. It did not. Cool. So you'll notice that this is what happens when you do catkin make. And it essentially is compiling not just that package, but your entire catkin workspace. So let me kind of go through what each of these things means here. And most of them we don't really care about. Oh, is this getting angry at me? Might be getting angry at me. Up top, that's just kind of where some of your more important folders are in terms of the paths, being that your source, build, install, whatever. This next chunk right here, we don't really care about. There's no reason why, that we really care about that. We could care less. The part where we kind of care is this section right here. And it says traversing 2 packages in somewhat order. You will have 1 package unless you've already created a package. For me, I have my first package in tutorials, and you'll notice that it says processing the package, adding a subdirectory, configuring done, generating done. And what that's basically saying is it's created all of the stuff necessary for you to actually go ahead and run your program. It is considered good practice whenever you make changes, or even changes, whether they be small or big, you usually run a cat commit just to make sure something didn't get messed up super bad. Okay, so now that we are here, we are ready to actually run the program. Now, how are we going to do this? Like I said, Ross is picky. Ross is, it needs a lot of stuff to run because that's just how it is. The first thing that it needs is a sort of core, might we add, might I say, some sort of core to run the rest of his programs off of. And the way that we're going to start that is literally by doing Ross core. And you should get something that looks like this pop up that just says, hey, Ross core is running. Here are your parameters. You should have Noetic or whatever version you're using. And there you go. Your Ross core is started and you're ready to run your node. Try clicking inside your terminal.
Yeah, I did.
That's fun.
You open a new terminal, what is it?
So you'll have to. Okay,
Thank you.
so now you're. I love that. Just close it and start it again.
It's not an issue unless it happens twice.
Actually. Okay, so we've got this started, but now we actually need to run our program. You'll notice that usually when we type something, we have this little Ross RMC Captain Workspace up there before we type in a command, but you'll notice here, we don't have it. It's just this white box that's blinking or not blinking, depending on what's going on. And what that means is that it's actually running some sort of program, and it's in the process of running. So we need to go to a new terminal. And the way we're going to do that is clicking this button up in the top left for new terminal. And what you should do here is the next thing is we're going to run a program or run a node. So what we can do here is we can do Ross run. And then the next thing you should check is to check if you've sourced. And the way that you can check if you had sourced is by typing out the first couple letters of your package. So for me, it's tutorials. So I could type out TU, and I should be able to hit tab, and it should autofill with tutorials. The fact that it autofilled with turtle means that I haven't sourced bash. Unfortunate. So the line that we're going to do, which is different from what we sourced before, is source /devil, because we're going to be sourcing the devil setup file, setup.bash. This line is going to be something that you're going to type in whenever you want to run a Ross quote unquote command in your terminal. So if we hit enter, we'll just go there. And now we should be able to do Ross run and have it pop up with tutorials. Boom, cool. And then the next thing we need to do is type in our file. So I'm going to type in sam.py. And this should work, right? Oh no, it doesn't work. Whatever shall we do? So what does the error message say? The error message says, couldn't find executable named sam.py. Unfortunate. But thankfully, we know how to make files executable. I'll probably need to re-record the Unix video because I didn't include this little nifty gadget of a command. But we need to essentially make our sam.py or whatever you called yours executable. And the way we're going to do that is by using a chmod command. So we're going to do chmod, and then we're going to do +x for adding executable. And you can look this up if you look up changing. I can probably link something with it with how to look at more. If you look up chmod Unix, it'll pop up. And, Yeah, there's a lot of really good Unix tutorials online. And then we need to find the file. And the way we're going to do that is actually we have to specify it through a file path. So I'm right now in my catkin. So the way I'm going to do that is by doing dot to reference catkin slash src slash tutorials slash src, get into the source of the tutorials, and then sam.py. Does that line make sense? Okay. Enter, we should go here. And now if we go ahead and run sam.py, oh no, what did that say? ROS.py is not, oh my gosh, I'm gonna hit myself. Okay, so I know what this problem is, and it's because I forgot a major line of code. Sam, do you know what I forgot? You're right.
Oh, yeah,
So you know those dependencies we put on the package, we actually have to reference those inside the program.
I actually got to look, I was like,
Oh my gosh, how did I forget? I was literally looking at my code over here too. Oh, that's so unfortunate. So, where's my cursor? So the way that we're going to do that, oh my gosh, geez, is we're going to go up here right under our first line, and this is where we're going to be importing everything. So we're going to do import ROS.py, and that's all you're going to do. Save it again. Go back to your terminal, and you can do a catkin.make if you really feel like it, but it's not that big of a change, so it shouldn't really, yeah, it's not going to do much else. And then you should be able to go back to your other one, run it, and it'll see if it gives you another syntax error. But instead, no. It just says, I know how to code many times. Now, yeah. Congratulations. You've made your first node in ROS. That actually does something. Now you'll notice that this is just going to keep on going forever because there's no reason in our code for it to stop. Unless maybe the server dies. I don't know. But you'll, what? Yeah, don't do that. So what's happening is in this while loop, it's printing something, sleeping, printing, sleeping, printing, sleeping. That's all it's doing. Super simple. So that's that. And to stop this program, this is a Unix thing. You're going to do it. Go ahead and hit Control or maybe Command for Mac users. I don't know what it is. Huh? Oh, so you're going to do Control C, and it should, once it registers the key, there we go. You'll see a little Control C down here. I don't know if you can see that very well. And then you'll get back to that green RNC, and then caption workspace. And then when you say your program is stopped, and if you want to run it again, you can easily run it again. You know, you can go ahead and do it, and that sort of thing. You'll notice. Stop. Okay. Okay. So there's a warning right now because it's using the same name, but I'm just going to say, you know, trust me on that. Don't worry about it for right now. We'll get to what that is later when we start talking about launch files. So if we don't start ROS core and we try and run the file anyway, it's going to say we can't do it. Unable to register with master node. If you get this, it means that your ROS core is not running. So that means that you need to go to another file or go to another terminal, start ROS core. Redo it. Cool. So that's basically the hardest part about all of this is just getting this basic idea. The next thing we're going to do is we're going to set up a super simple pub subsystem. Super simple. So same deal. We are actually going to go through here. Oh, what the heck? Lagging, I think. Go ahead and click source. We're going to do new file. And this one we are just going to call talk.py. And for simplicity, because we're programmers and we hate doing things, we can just Control A, Control C, Control V that's in here. Super simple, you know. We don't really, you know, we want to be able to make stuff as efficient as possible, and why, you know, go through and print or code everything again when you don't have to. So we're going to make a pub subsystem. And the idea behind this system is we're going to make a node that's going to publish a number to, let's call this one P and this one S, and it's going to publish some number to the subscriber, and then the subscriber is just going to print that same number. That's the idea of this system. How are we going to do that? Well, we don't really need this print line anymore, but honestly, that's about as much as we need to take out of this program. We can work with everything else, except one thing. Now, does anyone know what that one thing might be? No one's going for brownie points. Come on, Sam, you should know this. Bonus points to Sam. We need to change this init node name to whatever our new program is. So it's not sam.py anymore, it's talk.py. So boom, change that there and we're good to go. So we need to create a publisher really quick. Our talk is going to be our publisher, and we'll make one later that's listen. That'll be another publisher. So go ahead and hit enter, and we're going to go ahead and make a publisher, and we're going to name this pub to sub. Why not? Pub to sub. Usually, if you're actually coding, you want to make that a lot more specific, but it doesn't really matter for what we're doing now. And what we're going to say is we're going to say that this is a rospy.publisher, open paren, and then this is going to have 3 values in here. You can kind of see what's popping up here. We need a name for it, what topic name we're going to use if you watched the structure video. So we need a name of what topic this is going to be. We need a data type, and then we need a queue size for the publisher. So let's see, we're just going to call this num because we're just sending across the number. It's going to be an int64, which is a data type that we'll get into in a little bit.
Did you use single quotes?
Yes, single quotes. Yep. Python just really uses single quotes. I mean, you can use single and double interchangeably, but I usually just use single, up to personal preference. And then we're just going to do q_size equals 10. And that's kind of saying, Sam, you can correct, or I guess Jaden, you can correct me if I'm wrong here. But it's basically like if your subscriber isn't accepting things as fast as your publisher is taking them, it'll allow so many to build up in between before it just starts not sending them. So it's just a little, 10 is more than enough for what, the average person's going to be doing with it, unless you're specifically setting it up for some reason. Cool. So we have now made a publisher that we can utilize. So this int64 thing, I talked about how one of the dependencies that we're going to be using for this program is a standard message. And the standard message is essentially a collection of data types that include int64 and stuff like string or speed command for robocalls or joy for joystick control. Types of data, essentially. So we need to import it. We're not going to make that mistake again. So right under your import.rospy, you can do import std for standard _ msgs messages .msg import from the, actually, my bad, it's not import, it's going to be from, because we don't need all of the packages from standard messages. We're going to do from that import int64 for int64. And that'll essentially make it so that our number that we pass across can be very big before it starts getting angry. And that's all we really need from that. Cool. So let's go ahead and make a number here. So we can go ahead and essentially say, okay, we're going to have a global num, and then we're just going to set that num below it equal to 0. Okay. And then we have the rate, and then we're going to go ahead and we're going to publish that number. So the way we're going to do that is we're going to do pub to sub, so the name of our publisher, dot publish, right? Oh my gosh, come Making sure I don't get a syntax error here. Pub to sub dot publish, and then in parentheses num. So we're basically saying, hey, publisher that we just created, publish this variable. You know, if you have an object, you can go ahead, throw that object in there, whatever. And then after that, we're just going to go ahead and do a num equals num plus 1, just to iterate it off 1. And that's it. That's all we have for this this talk.py, this basic publisher. Now let's go ahead and make something to listen. So we click on source again, new file. There we go, listen.py. Listen.py, cool. And because we're lazy, we can go ahead and copy this all again, because why would we want to create stuff? Change this sam.py to listen.py. Get rid of the print statement because we don't really need that. And this subscriber won't actually need the while loop either. We just don't, yeah, whoa, kind of cool. We don't actually need a while loop, and I'll get into why here in a second. In this program that we're doing, the publisher is usually the driver. So the publisher is going to have most of your main computation for this specific program, and it's driving the subscriber. Subscriber is just kind of along for the ride. It's going to do what it's told, but it's not, you know, the main brunt of this program. So let's create a subscriber. So we can just do that one. We can create the subscriber. Oh, we actually, yeah. So we can create the subscriber by typing rospy dot subscriber. Oh, I misspelled subscriber. Rospy dot subscriber, open paren, and now this is important, is whatever you named your topic, it's going to take 3 parameters again. The first one is going to be that name. Whatever you named your topic in talk.py or whatever you called it needs to be what you're passing in over here. So we're going to have single paren num, comma, then we're going to have that data type again. So int 64, comma, and then a method that we're going to create that happens every single time it gets that data. So we're going to call this callback. Boom. So since we're using int 64 here, we're going to need to go ahead and import, not import, sorry, from cd mscs.msg import int 64. Is this all making sense so far? I don't think it's rocket science, but I'll also done this before.
I mean, it makes sense, but I want a deep understanding of why we're doing anything we're doing. So
Yeah.
that comes with time. So I get what we're doing. As far as I feel like I have to know.
Yeah, deep learning is fun, but you know, yeah. So num int 64, cool, and we don't actually need this rate because it's no longer using, but we're still going to keep the spin simply because we want it to always be active. So next important thing is making a callback method, and we're going to do that by doing the def callback, and then for stuff that's getting passed in, we're just going to say that this is data. That's just the data that is getting passed in from that subscriber, colon, to make it a function call. And all we're going to do here is we're going to do print data.data. And that's just kind of how you grab whatever you're passing along from that thing. It's just whatever your parameter here is, .data. I know it looks weird, but that's just kind of how it is. Yeah, so every single time that listen.py gets a ping, we essentially, it's going to send that data to callback will print it to the console, and we'll be good to go. So make sure they're both saved. And let's go back to the terminal. And we can go over here and do a catkin underscore make. Should be good to go. Shouldn't have anything major happen. And then we can do ROS core. Boom.
Can you repeat what you typed in that journal?
First was catkin underscore make, just to make sure that there wasn't anything that we screwed up too badly, which is more file system instead of code. And then I did ROS core to start the ROS core. And then if you go over to another terminal tab, actually, I'll just make a new one for this example. I can't still be running, can I? Hold up. I am? Well, thank you, my friend. I thought I stopped that before. They called me out on it. Well, I must have restarted when I restarted.
There's a fire in the room right now, then.
What?
There's a fire in the room right now.
Yeah, we're gonna get reports that dorm fire over in Knoll. So we open up a new terminal. Let's source that devil file. Source. Yeah. Oh, yeah.
It says ROS core cannot run as another ROS core must be.
Oh, so that means that you've already got a ROS core running, which is.
Okay, already called ROS core. When you call ROS core, we're gonna throw it. Okay.
Yeah, so you should be good to go.
Okay.
You should be good to go. So in your new terminal, since we're going to be doing a ROS run, go ahead and source your devil file. Setup.bash, pretty simple stuff. And then we're going to do ROS run, and then the name of your package. So tutorials or whatever you named it. And then I'm going to start this one with listen.py. Oh, wait, but it does autofill because we still need to make it executable. Plus x slash source slash tutorials slash source slash listen.py. And so I don't have to do that again. I'm going to go ahead and make talk.py also executable. Okay. Once you've got there, I guess, look up so I know that we're all on the same page. Cool. Yes. Okay. So if we want to, I guess the first one we're going to go ahead here and do is the listen. So ROS run tutorial, and then listen.py. And you'll notice that it's just, wait, why does it not like that? It's not a legal ROS base name. Didn't I low-key use it in this one? It was fine. Oh, okay. Yeah, okay, never mind. So it's it's running. We're just not going to pay attention to the error because it's not, or it's a warning. It's not an error, so we don't really care. What? So we're going to notice that it's running right here. If you want to see, we're going to open up another terminal to run the other one. You'll notice that nothing's happening right now, but that's because we have our subscriber. It's not getting anything, so it's not, doing anything. Come on, there we go. Go ahead, source that devil file. Here it is. Boom. And if you want to get a list, a command that you don't need to know, definitely not required, is something called ROS_node list. And all that's going to, let me just show you what it does. All it does is it's just going to show you what current programs are running. So you notice that listen.py is up there from that terminal. And then there's also a ROS out, which is something that just gets initialized whenever ROS core is running. So that's just kind of there, something to look at. And another command you can do to get a little bit more graphical representation of what's going on is RQT graph. So if we do R or ROS run, RQT, sorry, underscore graph, space RQT underscore graph, and hit enter. It'll load for a second, and then it'll pop up with a singular circle with listen.py. And that's basically saying this is your ROS environment right now. All it's got is a listen.py. You know, super simple. That's all it's going to be. Now let's see what happens when we go ahead and run talk.py. So ROS run tutorials talk.py. Enter. You'll notice apparently it doesn't like, I don't know why it doesn't like these names. But good. Okay. But you'll notice if we go back to the subscriber now, if we go back to the terminal with the subscriber, it's counting up 1 every single time because we have the publisher talking to the subscriber. Okay. Let me see what's up. What is the error? So does that make sense why we're getting a number that's just getting iterated up once? Yeah. If we want a little bit more graphical representation of what's going on here, go ahead. Oh no. Rest in peace, server. Go ahead. Here we go. Source that bash file. Yeah, I'm sure I'm killing your server right now. ROS run. Wow, it's lagging. RQT graph. And it should pop up with a little bit more graphical representation. That pretty much looks like this, actually, is what it should pop up with. So you'll notice we have talk.py, which is our talker program that is sending information along topic num to listen.py. Yeah.
I do not know that.
You do not have that. What? My goodness. My goodness. What do you got?
I don't know, it says, redo, it works.
Check your other terminals, see that where the ones where you're running top. Any other ones running top?
It looks like,
Like go towards the second terminal there. Yes. Are you running the top of any of the terminals?
Yes.
No, now because you had to close it to start the node graph. Okay. So go back to the terminals. You go to the last one where you were running top. Yes, you would have closed it to run the RQT graph because open another terminal and run cross talk.
What do you mean?
So what happened is if this one was running top, cross talk, the talk, sorry, not py.
Yeah.
But you ran the RQT graph in there. So in order to do that, either
So that should have ran over here.
no, I think you should run that in a completely different terminal. So open a new
Gotcha.
terminal and run talk in that. every time you run one of the things in the terminal, that terminal is essentially in use for everyone.
And build this thing.
No.
That thing.
No, you run the Ross run. Oh, I see the key. You can go to your Ross program. Did you save this program?
Yes.
Try and save it again. It has the dots, but it changes to it. See if you run it now.
Do I need to check this again?
No, just okay. Now check your graph. I don't know if that updates. Sorry.
No worries, thank you.
Oh, sorry. I closed all of my, or stopped running all my
Yeah,
programs.
thank
during this.
you.
Yeah.
Now you might be saying, Justin, what the heck? I have to open up a ton of terminals. Kind of sucks. And I would tell you, yes, it does suck. But guess what? There is a way around that. Something called a launch file. Oh boy, don't we just love launch files? A launch file is essentially going to be something that allows us to basically start multiple programs at the same time. It is just very, very nice to work with. So how are we going to make one of those, you might say? Well, we're going to make one right in here. It's just another code file. So make sure you click out here so you get this blue box, because this file does not go in the source. And you'll hit new file. That looks like it's inside the source. I guess if it's inside the source, you should just be able to do. We could just do tutorials. Oh, wow. Dot launch. And you can name that whatever you want. You should get like a little orange weird Wi-Fi signal thing. Oh, it's outside. Cool. And how to know if it's outside of your source is you should be able to click this arrow next to source, have all three of those Python programs that you wrote disappear, and still have your launch file on the outside. Important that it's out there. So the syntax for one of these things, super easy. We're going to start it with, if you ever written, it's basically XML, I think. It's a form of XML, I think. I don't know. So what? Yeah. So we're going to start this with launch, and you're going to do an open, what is that, like less than sign, I think. Less than sign, launch, greater than sign, enter. And then you can actually hit enter a couple of times, because then below all of this, to close it off, we're going to have another one of those that looks exactly the same, except there's going to be a slash before it. So it'll be, I'll do open caret slash launch closed caret is what I'm going to call that. And that's just kind of a syntactical thing. When you start stuff, you open it like that, and then when you end it with lab. Let's create a node really quick. So the first node we're going to create is the talker. And essentially, we're going to, I guess, do open caret node. And then we're not going to do a closed caret yet. We're going to do this all on one line. If you're going to do it multi-lines, you would want to use a closed caret and then a slash whatever thing later. But we're going to do this all in one line because it's simple. Do node name equals, and then whatever you want to call it. This is important as long as it's just unique. So I'm just going to call this talker. And then I use double quotation marks for this because I think the language likes it more, but I don't think it honestly matters. Space package equals, and then whatever your package name is. So whatever is right up here, that's your package name. Go ahead and type that in there. So package equals tutorials, quote mark again, and then type equals, and then this is the program that it is. So at this point, we know what package it's in. We don't know what type of file it is. So we need to tell it that it is a type talk.py. And then you're going to do closed quote, space / closed caret. And just like that, the launch file, when it's run, will initialize a node that is a type talker, so an actual talker program inside the tutorial package with the name of talker. Okay. And then if we let's create a listener here. So if we do node name equals, I'm just going to call this ear1. Parenthesis EKG equals tutorials, and then type equals listen.py there. And then the last one we're going to do is, you know what, let's make this look cool. So we're going to have another node that's going to be ear2. Package, same deal. Type equals listen again, because remember, it's just another version of the listen file. And then we're also going to create a, we can just create, you know, it's simple enough, just one more line. Let's create a version of Sam, or let's create an instance of Sam. So node name equals, I don't know, we can call it person. Package equals tutorials again, and then type equals sam.py. Cool. This should be kind of what it looks like, and it should be fairly straightforward. And now that that's saved, go back to your terminal. Oscore still running, cool. Go ahead and do a catkin make, just because, again, should be super simple. And now, instead of needing to go through and make 4 new terminal windows, source the dev folder 4 times, you know, do ROS run 4 times, we can just do ROS launch the package we're in, so tutorials, and then the actual file. So you should be able to just tap tab twice, so double tap tab, and it should give you a list of every program that you could put in there. Since there's only one, it'll just autofill it to tutorials.launch. Hit enter, and you'll notice that we get something that looks kind of like ROScore, but it just says, hey, here are all of the nodes that we're running, that this ROS launch folder is now running. There's the master, and then there's going to be some processes.
What terminal do we put this in?
Oh, just any terminal that's not.
So many open, okay, then I want this in there.
It close everything, you shouldn't have anything open except for one that's running like ROS cord.
Okay.
ROS cord doesn't need anything running in the background.
Yep. And if it's a new terminal, remember you're going to need to source your devil file. So we got this, and you'll notice that it's blinking there, but there's no numbers coming out. There's no I am a coder coming out. Well, it's happening in the background, and we could look at it, but we don't, you know, we don't really need to. There's just not, you know, we don't want all of that information. Imagine if you had a much more complicated thing. If we do the ROS node list, you'll notice that we have all of those programs coming out, but those programs are the ones that they have the names. Instead of having the actual program before, it's the actual name. So what that name parameter does is it actually goes into the program, finds the rospy.init name or whatever that we put in there, and it replaces it. Okay? Because when you're making these programs and you're making a collection of programs, you're always going to have a launch file. So your init should pretty much always be just the name of the program because it's going to be overwritten anyway. Okay? And if you have any other parameters such as ports for roboclaws or speed command count, I don't know, it would go in that launch file as well. So if, again, we want to see the visual aspect of this, we do the Ross run RQT graph. This one will look kind of cool. So you'll notice that we now have our talker that is sending information to ear 1 and ear 2 on topic num, and then we also just have the person in the background that's not connected to anything that's still running. Does this make sense why our graph looks like this? Yeah? If we wanted to create another publisher or put another publisher in there, I do that in the video. I actually have a string one that just processes something else. You can watch the video for that, but this is just basic kind of how this works. Do you guys have any questions on this? Okay. Because that's pretty much all I have for today, honestly. I think you guys at least learned something, even you, Sam. I doubt it though, maybe, probably not.
I didn't actually know the right one.
Oh, yeah.
That's the one thing I didn't know how to do actually.
Yeah. Yeah, I might make a video on rewriting once I send it. That'll probably be over break, honestly. I have no time to do that right now, but rewriting actually isn't that bad. Yeah, so does anyone have any questions on anything? No? Cool. I guess I did a halfway decent job. Cool. In that case, for the YouTube people who are potentially watching this, yay you for sticking through it all. You know my policy. If I said something wrong or you don't like something, throw it in the comment section and make sure to like, comment, and subscribe. And hit the little bell for notifications if you enjoyed the video. Yeah, I only have 7 subscribers and I have a lot more than 7 views on certain videos. So that tells me that y'all aren't subscribing. So seems very sus. Yeah, what the heck, people. But yeah, that's all for me. Hope you learned something. See you in the next one.